Thank you, Tracy. So I am here to talk to you about the science of authenticating Angular applications. And Tracy already sort of said a lot of this, but my name is Kim Maida. I was actually promoted to the head of developer relations at Auth0. Auth0 is an identity and access management company. I'm a Google developer expert in Angular and web technologies, and I run the Angular Ann Arbor meetup. Now, I work in the field of identity and access management. And when I saw this tweet, this really sort of resonated with me because it's something I see a lot. So developers come onto a project, they're tasked with working on the authentication code, and then their lived experience ends up looking something a little more like that. So I want us to take a little bit of a step back here and do sort of an introduction to authentication for web apps. And I mean all web applications, not just single-page apps. So if we go back and talk about cookie-based authentication, for example. Cookies are how we traditionally secure applications that are sort of back-end web apps, things that are built in sort of like PHP or .NET, for example. And the way that cookie-based authentication works is something like this. You have your browser, and then on your server, you'll have a back-end application and maybe a database. And when the user is going to log in, they submit their credentials through the browser. Those credentials get sent to the server, which verifies them. And if everything is successful, then the server is going to set a cookie in the browser. Now, this cookie represents the user's session. And at this point, the user is authenticated. Now, on subsequent requests for pages that maybe contain sensitive data, or whenever there's traffic to this domain, then what's going to happen is that cookie is automatically attached with the request by the browser. And this is a browser thing. It'll just do this automatically. It's sent to the server. And then if everything checks out, then the server is going to return any HTML and sensitive data that the user requested. Now, if the cookie's expired or there is no cookie, then and a request is made for protected data, then what's going to happen is the server is going to return a 302 redirect status. And what this is going to do is it's going to tell the browser to do a full page redirect to go somewhere where the user can re-authenticate. Now, once that is done, then the server is then able to send secure data once more. Now, we are Angular developers, so we traditionally build single-page web applications with Angular. And the method of authentication that's more popular with single-page apps is to use token-based authentication. This works a little bit differently from cookie-based auth. It looks something like this. Again, we have our browser. And when a user navigates to our application, what happens is that application is compiled, downloaded, and then it runs in the browser itself. So where we get data is traditionally from APIs. Now, the authentication process itself is often done using something called an authorization server. And really what this is it's just kind of a fancy word for a set of endpoints whose purpose is to issue tokens. So when the user submits their credentials to log in, once they've done that with the authorization server issues a token which gets sent back to the application in the browser. We can then send tokens with HTTP requests that we make to our APIs to get data. And the API is then going to verify the token with middleware. And if everything checks out with the token, then data is returned typically as JSON to the browser. Now, here's a question, though. Why do we do this? Why don't we use cookies for single-page applications? And it really comes down to the fact primarily that cookies only work on the domain of the application. So if everything is on the same domain, your API and your application, then that's great. Cookies are going to work out for you in this case. But many single-page applications call APIs that may live on different domains. Or if they don't right now immediately, they may need to scale and do so in the future. So if you have an API that lives on a different domain from your application, then that same session cookie is not going to work because they don't work cross-origin. Now, maybe this is you. Maybe everything is on one domain. Your API is on the same domain as your front-end application. And actually, if you have that type of architecture, you may very well want to consider using cookies to secure your application. So if you have stable architecture, you're not calling any third-party APIs, you are pretty sure you won't be in the near future, then you should consider doing authentication with routes that are served from your back end. And then you can just use cookies to secure the data that moves in between the single-page application and the back end. There's one thing that you do have to sort of keep in mind if you're going to do this, though. And that's if we go back to how all of the whole dance works with the server and things, then when an app uses cookie-based sessions, and a user tries to access a page, then if they're not authenticated, that server returns that 302 redirect status, right? And then it redirects the entire browser to somewhere where the user can log in again and get authenticated so that a cookie can be generated. On the other hand, single-page applications request data using AJAX calls. So in this case, if the cookie is expired or there is no cookie, then the response that they get is still going to be a 302 authentication redirect, right? Because we're using sort of the structure of securing the entire ecosystem with cookies. So in your single-page application, that expects a response that's in the form of JSON, I'm sorry. So you'll need to add logic to the application to handle what happens when it gets a 302 status instead. And this is fine. A lot of applications do this. It's not really that much work to add this in and to sort of prompt the user to go somewhere to re-authenticate when you get a 302. But if you do know that you're going to need to scale, or if you already have APIs on other domains, or you know you're going to implement some soon, then really the solution is to use tokens. So on the topic of tokens, I want to talk for just a moment about storing them. And really, you should not store sensitive data in local storage. The problem with this is local storage has a distinct lack of data protection. So here are some of the concerns that we would need to keep in mind when we put something into local storage. For one thing, local storage is accessible to any JavaScript that's running on the page, which means that something like a cross-site scripting attack, if you have a malicious script on your page or a compromised third-party script, then anything there could read the local storage object and steal anything that's contained within it, which could be something as sensitive as a token, which gains users access to your APIs. Now, cross-site scripting can also sort of work the reverse way, and you could load malicious data into your local storage. Something malicious could load malicious data into your local storage, which can potentially make it somewhat of an untrustworthy source. And then finally, all local storage is shared within an origin. So what this means is that if you have multiple apps running on the same domain, then they all have access to that same local storage object. And if they all have independent authentication, then you can see how this might get messy really quickly. But the most common reason that we put tokens in local storage in the first place when we make single-page apps with authentication is for session persistence, right? Because the user still needs to have the token if they refresh or if they leave for a short period of time, they come back. It's not a great user experience if we're making people re-log in every time they come back, even if they were only gone for a second. So the question becomes, if we shouldn't store tokens in local storage, then how do we do this and still maintain that session persistence? And really, you should store sensitive data in app memory. But this doesn't solve the session persistence problem, right? So when a user authenticates, what happens with an authorization server is that it's going to set a cookie in the browser. And this cookie represents the user's session with the authorization server itself. So the cookie doesn't actually contain sensitive data. It just tells the browser, yes, this user is recognized by the authorization server, and they have an active session with us. So then if we refresh the browser, we're going to lose all of the tokens and data that was stored in app memory. But what we can do now is we can check that cookie. This is called check session. And if the cookie is still there and still valid, then we know that user has an active session with the authorization server. And what that does is it allows us to request new tokens silently without prompting the user to re-enter their credentials. So with that said, there's some guidance around using token-based authentication with single-page applications. And I'm going to start out with just a really quick history lesson. In 2012, when the OAuth 2.0 spec was initially adopted, single-page applications weren't mainstream yet. So for example, AngularJS didn't really become popular until around 2014. So at the time that this spec was written, it wasn't really written with single-page applications at the forefront. So historically, the advice that was given in OAuth 2.0 was that tokens should be delivered via a browser redirect. So what this looked like was something like this. The authorization server would send the token back to the application in a hash fragment in the browser. Now, there's inherent security risks with doing something like this. For example, the token is vulnerable in a number of places with this paradigm. It's vulnerable in the redirect URI, which could potentially be, the whole thing could be hijacked so that the token gets sent to the wrong redirect URI, and then whoever owns that redirect has access to the token. It's also accessible in browser history, which JavaScript can access. So if you have XSS attack, then it can read all of your browser history and just grab the token straight out of there. And then also, it's potentially accessible in the refer header. So if a malicious page was requested right after authentication, then that token could be grabbed out of the refer header as well. Finally, the last part of this is that the application itself doesn't sort of automatically know where the token that it's being given came from. Now, it could have been maliciously injected from somewhere else. It could be somebody else's token. You could be having like a privilege escalation attack. So the thing is, though, authorization servers and application developers have worked for years to mitigate these types of security risks. There's no new threats to this approach. And I want to make that really clear. There's not any new attack that has come out that all of a sudden makes doing this way more dangerous than it has been for the last 7 years. Nothing new has changed there. So the same mitigations will continue to work. But the thing is, now modern JavaScript is really just eating the world of web apps. And what this means is it's just time to recommend new best practices. So maybe we don't have to worry about these mitigations so much anymore. And the new best practices is actually the same approach that's used in mobile applications. And the way that this works is you have your single-page application running in the browser, you have your authorization server. And I'm going to go through this a little bit quickly, but essentially the gist of it is this. In your single-page application, you want to create a high-entropy random string. This is called a code verifier. And then from that code verifier string, we're going to compute another string, and this is called the code challenge. And we're going to use a hashing method called the code challenge method in order to compute this code challenge. Now, when the user goes to log in, we're going to send the credentials and the code challenge to the authorization server. The authorization server is then going to generate a code, and that code is going to be sent back to the browser and received in the URL in a hash fragment. And this is actually fine, because interception of this code by itself isn't dangerous. The code alone is not going to give an attacker access to anything. Because what we need to do now is once we have that code in the browser, then what we are going to do is send the code and the code verifier to the authorization server. So this is a multi-step process now. And what is going to be done next is on the part of the authorization server itself, it's going to use the code challenge method, which it was given earlier, and it's going to calculate the code challenge from the verifier. And then it's going to compare the code challenge that it calculated itself against the code challenge that the application sent in sort of the first pass with the credentials. Now, if those two challenges match, then a token is issued, and it's going to be sent to the application in a JSON object. So basically, all of the mitigations that I talked about before, with all of the risks that are inherent in putting the token in the URL, none of that's really needed anymore. And if you want to read more about sort of how this works, you can check out the draft for best practices for browser-based apps on IETF. The link is at the bottom there. And this is a lot. right? It's a multi-step process. There's like, you have to generate all these random strings, and there's hashing involved. But the nice thing is authorization servers and sort of open source maintainers, people in the security world, have created SDKs that will offload all of this work. So you can use an SDK that will handle all of this for you. So if you have a greenfield application, you're building something brand new right now, and you need to add authentication to it, you should probably consider using the new approach. It's just more secure, and you don't have to worry about all of these other mitigations. But like I mentioned before, there's no new threats. So for existing applications, if you have big applications running in production, if you have things that you're already sort of down to the wire on, there's no new threats. If you've mitigated the risks to the sort of the approach that was initially drafted in 2012, you're okay. It's not going to be the end of the world. But if you can consider switching, then you probably should. Which brings us to the second half of my talk. This is an Angular conference. So how does Angular as a platform help us deal with authentication and the things that we need to take into consideration when we're authenticating apps? And what I'm going to do in order to address this is sort of an Angular authentication to-do list. I'm not going to stand up here and live code a to-do list. It's really just a checklist of things we want to remember. So one thing we want to be able to do in Angular is elegantly manage authentication events. This could be things like token availability. It could be user info. It could be login status. We need to be able to send the token to our API with API requests. And then finally, we want to be able to restrict access to certain routes in our application. So if we take the first item, managing authentication events, Angular has this awesome library packaged with it called RxJS, and this can really, really help us out in a number of ways. And one way that it can do this is it can help us interact with SDKs reactively. So I know that probably many of you have used other libraries, other SDKs. By and large, if they're not built for Angular, they're not reactive. They use sort of async await or promises or callbacks or something like that. So what we can do with RxJS is we can turn things like that into observable streams for easier consumption in Angular. For example, maybe we are using an authentication SDK, and that SDK maybe provides a callback that is going to return token data from our authorization server. So what we can do with RxJS is we can use something like bind node callback or bind callback, depending on the type of SDK that you're using. And this is going to create an observable that emits when that callback completes. So once you have something like that, then you can subscribe to this observable. And then you can also pass it options. You can pass options to the bound method at the time of subscription. And then you can do something with the result when that data becomes available. Similarly, if your library returns promises, then we can use the from observable creation method in order to convert a promise to an observable. So the other part of this whole cycle that RxJS really helps us with is creating streams of data to help us know when things are happening. So for example, like I mentioned before, token availability, user info, login status. So if we take the example of user info, we could do something like creating a private behavior subject in our authentication service, and this could represent our user data. And then when this data changes as a result of authentication events, then we can use the next method to to emit new values from this user stream. And then, because our behavior subject was private, we can publicly expose it as an observable to the rest of our application, which allows us to subscribe to it and then react to changes. We could sort of make changes in the UI, show the user's name in our template when they get logged in, things like that. So these are really just a couple of examples of how RxJS can help us to manage things that are sort of related to the ecosystem of authentication. And I'm sure you can find a lot more ways to do this on your own. If you do, I would love to hear about them, so please let me know. So if we go back to our to-do list, we have now learned that we can elegantly manage authentication events by taking advantage of RxJS. Which leads us to the next item, which is sending the token with API requests. Now, we use HTTP interceptors to do this. And what these do is they transform requests or responses. So when we call our API, we can intercept requests using an interceptor service. And as we're doing that, we can attach an authorization header with the value of our token. And then we can send the whole thing on its way so that it is then authorized and the API has the token when it receives the request. The way we would do this is in our app routing module, we have this providers array, and we're going to want to provide the HTTP interceptors token from Angular Common. And then we're going to provide a class that tells the interceptor what its actual functionality is. And then we can set multi to true, because we could define multiple interceptors. And if we do this, they're just going to run in the order that they're provided. So if we take a look at that interceptor service class, in it, we have some necessary setup, which isn't shown here. There's an intercept function, and inside that function, we might have something that looks like this. So first thing we're going to do is we're going to clone the original HTTP request that came in. It doesn't have the header yet. We're going to set the header on that cloned request, and then we can send it on its way to our API. Now, Angular doesn't have a way out of the box to only put interceptors on specific requests, but we can just use traditional good old conditional logic to do this in our interceptors ourselves. So as sort of a simplified example, you can clone and modify the request based on some condition that you define. For example, you have access to the original HTTP request, so you could grab its URL, see if the endpoint should be secure, and then if so, clone if necessary, and if not, then just send the original unmodified request on its way. Another thing we can do is we can create asynchronous interceptors. And this can be particularly useful if we have a page, for example, where when you come to the page, requests are made without some kind of user interaction. So we need to make sure that the user is fully logged in, the application knows that they're logged in, they've got all the authentication information before we actually go and start sending requests to the API. So maybe we could use RxJS to do something like create an auth token stream in our authentication service. And maybe this will emit the token once it becomes available. And we can use merge map here to ensure that if we have multiple requests that are being sent out, that none of the previous requests are canceled by a new one that comes in. So now if we come back to our slideshow, which died. Sorry, don't know why that happened. Okay. Keynote quit unexpectedly. Thank you. Never would have guessed. OK, so back to our to-do list. We now know that we can use interceptors to send the token with API requests, which leaves the last item, which is restricting access to certain routes. So many of you are probably already familiar with route guards and the concept of route guards. Route guards implement 3 different interfaces. And the most commonly used sort of default one that everybody learns is called canActivate. And what's significant about canActivate is when you protect a route with canActivate, the code for anything that's behind that route is actually still loaded in your bundle. So it's still going to be in the browser. It's still accessible to somebody who's savvy with dev tools. And if they want to look at the source, then they can see everything that's in there. Now, canActivate child prevents unauthorized users from accessing children of a specific parent. But it works similarly. Again, the code is still going to be in the bundle. Now, the last one is canLoad, and this one's a little bit different from the other two, because essentially it prevents lazy loaded modules from downloading to the browser in the first place if the user is unauthorized. And we'll start with canActivate. So in our app routing module, when we set up our routes, then we're going to use the interface name as a property in our route settings, and then we can pass in an array. So we can have multiple guards. They're going to run in the order that they're provided. And our authentication guard service might look something like this. We're going to have a canActivate function, and this function is going to return an observable, a promise, or a Boolean. So in this first example, I'm just going to return Booleans. But in my canActivate function, I can deny or grant access based on some condition that I define. So maybe my authentication service has an isAuthenticated method that just returns true or false, telling me if the user's logged in or not. If they're not logged in, I want to return false from this function to tell the browser that access should not be allowed for this user to proceed to this route. I can also do something like sort of a side effect. I could navigate them off to a login page to indicate that they should probably log in if they want to access that section. And then if they are logged in, then I'm just going to return true. Now, guarded lazy loading works a little bit differently, because we're going to asynchronously load sections of our application only for the authorized users. And it still holds true that you wouldn't put sensitive data directly in your front end. It's just things like that belong on an API where it can be additionally protected. But this does give us a couple of benefits. It gives us a little protection, and it does give us smaller bundle sizes, which can be really helpful. So in our app routing module, when we're setting up our routes, we're going to lazy load a routed module. And in this particular example, I'm using an admin module. So maybe this is a whole collection, it's a whole section of the application that only people with admin privileges should be able to access. So I'm going to use my canLoad property. I'm going to pass in a guard, in this case, called role guard. Now, this guard I could potentially use with various different roles. So maybe if the user is supposed to be an admin, I have an admin section, I have an editor section, I have a user section, etc. And how it's going to figure that out is by using route data. So I can pass in an object to this data property. I can say the expected role for this particular section is that the user should be an admin. Now, my auth role guard is going to have a canLoad function, similar to the canActivate. And this function, again, is going to return an observable, a promise, or a Boolean. And in this case, I'm actually going to be returning an observable instead of a Boolean. And inside my canLoad function, I might have something that looks sort of like this. So if we come in here, maybe I have a stream for my isAuthenticated status now. It's going to emit true when the user's logged in. It's going to emit false when they are not. And what I can do here is I can use something like the tap operator to execute side effects if I want. So I check to see if the user is logged in. If they're not logged in, then I can do something like, for example, have them log in and redirect them back to this place. So in our canLoad guards, we actually have access to something called segments, and this is a URL tree. So we can get the URL, the target URL that the user is trying to get to. So once I have access to that, I can maybe call a method for logging in, and maybe that method has a way to redirect the user back to a path that I pass in after they're successfully authenticated, that they don't have to sort of navigate back through the app and find their way back here on their own. Now, if the user is logged in, but maybe they don't have the role that I expected, maybe they're just a user and not an admin, then I could do something like redirect them to an unauthorized page. So if we come back to our list, we have now covered how to restrict access to certain routes using the various different types of guards. And we've basically finished this list. So in this talk, in the first half, I basically covered authentication basics, talked about some best practices, and then also I covered some strategies that you can use with the Angular platform itself to help you make authentication go a lot smoother, be much more palatable and digestible when you're tackling it. So the slides for this talk are going to be posted here after I get off stage. And I really appreciate you giving me 30 minutes of your time today. Also, I have t-shirts, stickers, and a Polaroid camera. So if you want to talk about, if you want any of those things, or if you want to talk to me about auth, please do. Thank you very much.